we actually tier all the different machine learning projects at Uber into 4 different tiers, with the tier 1 being the most business critical project. You can measure some proxy metrics. How many models we trained last week? How many models we deployed? For those users, we provide a way for them to directly access the infra layer.
Michelangelo is the machine learning and AI platform for Uber. All of the AI and ML use cases are powered by Michelangelo,
Yep.
which is a feat. That's a freaking crazy thing to say, just because of how many use cases you have.
So we're actually open sourcing Machanjo. Do you want to touch base?
No.
We are.
What?
Yeah.
Holy shit.
Let's align on something first.
Yeah.
That is the definition of AI. Because nowadays everybody talks about AI. Even my mom asked me, "Hey, I heard you're working on this artificial intelligence thing. What exactly are you working on?" So I think when a lot of people out there talk about AI, they think of ChatGPT.
Yeah.
That's what AI means to most of the people out there. But from the AI platform perspective, AI is not just ChatGPT. AI is not even just the large language models or generative AI, which is technology behind the ChatGPT. AI actually covers the whole spectrum of machine learning, from the very simple linear models to tree-based models like random forests and XGBoost, to the traditional deep learning models like convolutional neural network and recurrent neural networks, and all the way to generative AI. Yeah. So let's keep that in mind, and then let's talk about Machanjo. So Uber's AI journey started back in probably 2015, when a few teams like maps, pricing, and risk, they started thinking about, if it's feasible to replace the rule-based systems with the machine learning systems. Yeah. So when this team started, they all built their own one-off workflows or infras to support their machine learning needs, for like training models or deploying models. These are, the random or ad hoc Python code sitting in notebooks. So these notebooks were very hard to manage. They're very hard to share. So it's basically non-reusable or non-shareable.
And non-shippable.
Non-shippable, exactly. Very hard to productionize. Yeah. And impossible to scale, which leads to the inconsistency in performance and also duplicated efforts across teams at Uber. So that's actually where Machanjo comes into play. So Machanjo provides this centralized platform for our machine learning developers to manage the whole machine lifecycle end-to-end without worrying about the underlying infra and system complexities. So that's why we actually started building Machanjo back in 2016.
Yeah, get that scalability. And I think there's something super cool that you pointed out in the recent blog post. Well, recent, like it's now a few months old.
Yeah.
On from predictive to generative AI and how Michelangelo has had this journey. And you talked about how folks want their own way of doing things. And so you have this centralized platform that's supposed to be helping them and streamlining things. But then you have those people that are pushing the boundaries and they're pushing the edges and they're asking for, hey, we want more deep learning use cases, or we want to be able to support deep learning use cases. And then you had to go and figure out how to make Michelangelo adaptive for that. And so the flexibility on that platform, can you talk a little bit about how you thought about that?
I think one of the lessons we learned along this journey is that you should let the developers choose which tool they want to use. So what we did is that we provide a abstraction layer on top of all the infra, complexities with the pre-built templates and pipelines for, I want to say, more than 80% of the users, for them to easily build machine learning applications. And for the rest, like 20% users, these are the advanced power users, as you mentioned, they want to build highly customized workflows. They want to use different trainers to train different models. For those users, we provide a way for them to directly access the infra layer. For example, we have a tool called Uniflow, which is an orchestration framework, Python orchestration framework, which allows our users to write their own code to customize their workflows and directly access the Ray clusters to run their own training and then deploy the models on Machanjo. So that's how we think about this, 80% and 20%.
Yeah, and speed that process up so much, I can imagine, from that time that you have the idea to actually like deploying the idea is unreal. Is that something that you look at as a key metric?
Yeah, if we talk about North Star metric for Machanjo, right? Let's go back to the Machanjo goal here, because the success metric is supposed to measure how well the product meets the product goal. So Machanjo goal is to provide best-in-class machine learning capabilities and tools for Uber's machine learning developers, for them to rapidly build and iterate high-quality machine learning applications. So there are two keywords here. One is the rapidly, which measures the developer velocity. That's what you just mentioned. The ideal metric is time to production. Basically, from the ideation of a project, how long does it take for that project actually launch into production? So that's a very nice metric on paper, but it turns out very hard to measure in practice.
That was what I was going to ask. That's so funny that you say that.
Yep, I can tell you why, right? First of all, use cases, they're all different. There are use cases you just need a linear model. The other use case, you probably need to train a large language model from scratch. I'm just giving an example. So you can imagine the time takes for these two different projects to launch is totally different. And the second variable here is the team capabilities probably. A engineering team with 5 machine learning engineers, everyone has like 10 years of experience, probably can do things much faster than a team consisting of one applied scientist who just graduated. So we also see this kind of difference based on our experience.
Unless they're going on vibes. These days, coding, the vibes can take you a long way. Jokes aside. Didn't mean to derail you. Then it's true that you do have these very different teams, capabilities and maturity levels and how they attack the problems. And then you also have these different use cases that if you're training a large language model, it's very different than if you're just using a random forest model. And you can't take the average of those and then think, our time to velocity is decreasing, or over the last quarter it increased because we trained some large language models,
Yeah, it's really hard to systematically measure this metric. But what we do here is we do two things. The first thing is we work with individual teams. Just watch how they actually use Machanjo to launch their project. So we get some anecdotal feedback from these teams. For example, our rider pricing team, they shared feedback saying by using Machanjo, it actually reduced their engineering cycles by 80% compared to them building everything by themselves.
Oh, interesting.
Yeah, so we have such anecdotal feedback from a lot of
subjective
users.
In a way.
Subjective, and each team has their own way to measure speed or to measure the engineering cycles. The second thing we do here is that this North Star metric is really hard to measure, but we can measure some proxy metrics. Things like, how many models we trained last week, how many models we deployed, how many evaluation pipelines we run, how many eval reports are generated. All these proxy metrics can be an indirect indicator about your developer speed, developer velocity here. So we track all this systematically on Machanjo level.
It's funny, now is probably a good moment to bring up to when you talk about evaluation pipelines, you're probably talking about the predictive ML evaluation pipelines less than the new
Actually
generative. You're talking about both.
Actually both.
Okay.
But they're totally different.
Okay.
I got your point. I see where you're coming from. But they're totally different.
So in a way, you're looking at all these proxy metrics. You probably have a page or a spreadsheet of them, and you can see if they're going up, we're doing more is good. Right? And less is bad. That means that there's something that's slowing people down, and you can correlate that to that North Star metric of velocity.
So we track this at two levels. One is at the Machanjo level. We look at all the training pipelines run last week or all the models deployed last week.
Yeah.
That gives us a very good idea about the velocity or how people are using our platform. We also track this at project levels. For each project, we have a dedicated dashboard to show all these metrics for that dashboard, just for that project.
Yeah.
So we know if there's certain things going wrong with certain projects, we need to fix. So we do it at both levels.
It's worth noting that all of these different projects, I'm sure you are powering a million different models that I can't even fathom, because I was telling you earlier before we hit record about a few blog posts that I read that were more on the predictive ML side, and it was a breath of fresh air to read these posts about, and one was around recommender systems out of application, and the other one was, I think it was like a multi-armed bandit scenario.
Yes.
And they were so unique. These use cases were like, wow, this is so cool to see how mature and how advanced these use cases are. And it made me think, when you enable the teams, when you have something that's not blocking them and they can quickly iterate, like you were saying, evaluate if it's worthy to continue forward, and then get it into production, you can throw ML anywhere. It's like the more creative ideas, the better.
Yes, you can. Yes, for sure. You can throw ML everywhere, but do you want to do it? Because ML is expensive, right? Especially if you want to use deep learning, it's very expensive.
Yeah.
Does your use case actually require machine learning, or even deep learning? That's the first question you need to answer, because the machine learning doesn't come for free.
Yeah.
So you have price to pay. It's so expensive. So do you actually want to do it? You want to evaluate on that front first, then start building your project, training your models, prepare your data, train models, deploy models, do things like that.
And are you looking at the cost? Because I remember in the From Predictive to Generative blog, you talked about how there's different tiers of model support.
Yes.
And so if it's obviously the RIDE ETA, that's probably one of the most important models that can never go offline ever. And then if it's something maybe a little bit more experimental, you are more relaxed about it.
Yes. When Machanjo started back in 2016, at that time, our mission was to enable machine learning for Uber. Basically, get Uber started with machine learning. And at that time, when Machanjo started, we only had 3 use cases on Machanjo, but now we have 1,000.
Yeah.
So
and each one has their own dashboard.
Each one has their own dashboard.
And you are looking at, hey, if the metrics aren't going right, we got to go look and see why.
Yeah. For example, if your model performance degrades, it automatically sends out alerts to that team. And then they look into why.
And for you, if they're not shipping enough, then you're going to go look into why. Is there something blocking them in the platform?
Yeah. Is there some system bug that blocking the development? Is the pipeline does the pipeline keep failing? And those things we need to look at. So
but anyway, sorry, I distracted you.
Oh,
but
no worries.
Thousands of dashboards, it just blows my mind. Yeah.
Yeah. So whichever team want to use machine learning, come to Machanjo. We'll help you get started. And fast forward a few years, actually most of teams, they already had incorporated machine learning into their core user flows. So this is I think the end of 2019, early 2020. So at that time, we actually pivoted our strategy a little bit. Instead of focusing on enable machine learning, because that's already done, we pivoted to improving the key project performance. That's when we introduced that machine learning tiering systems. So based on the business impact, mostly based on the business impact, we actually tier all the different machine learning projects at Uber into 4 different tiers, with the tier 1 being the most business critical project. Some examples, like you mentioned, pricing, matching, like rider-driver matching, and also ETA, fraud detection, those things, right? If this model doesn't work, it will cause a highest level outage for Uber services.
Yeah.
So these are tier 1 projects. And all the way to tier 4, these are some personal experimental projects. Like you mentioned, the users just want to try different things. So those are tier 4 projects. So today we have about 40 tier 1 projects, about 100 tier 2, and 500-600 tier 4 projects.
Wow.
So that's how the tiering system works. And when it comes to prioritization, right? Which project should we support first?
Yeah.
Then it's very clear.
Yeah.
We should focus on tier 1 first, then tier 2, then move on tier 3, tier 4.
Yeah.
And a lot of times, we just don't have bandwidth to support tier 3 and tier 4, to be honest.
The majority of the use cases still, and I can bet that almost all of those tier 1 use cases are still predictive ML versus generative
Yes.
AI.
Again, to be in the tier 1 project, you have to be in the core, Uber's core user flow. Meaning when user book a ride or order food or buy some grocery,
Yeah.
is your model actually in that critical path?
Yeah.
If it's not, that means you're probably not tier 1 projects. So based on that definition, 100% of our tier 1 today, they're still predictive ML.
Yeah, and I can imagine there's been a lot of people that have tried to think about ways to put generative AI into that core product. But when you think about the flow of me signing on to an app and then getting a car or getting food, where can you even put it in, right? That's
Very good point. Very good question here. There are some scenarios and use cases, I think, where we can actually apply GenAI and to improve the experience. For example, we're actually working on 2 projects right now on the Uber Eats side. The first project is we use the large language model to improve the personalization experience, to generate better dish descriptions, to actually match your users' interest to what we actually show on the East home feed East home feed screen. That's one thing GenAI can really help.
yeah.
The second one is we actually use large language model to improve the search quality. When you search something in the East app, we actually use large language model to improve that search quality.
Because it can pick up if I'm saying I want something fancy. Then it understands fancy a little bit more than if it were traditional.
Semantic understanding. Yeah, that's one thing. And also, we can use the large language model to build taxonomy of all the dishes and restaurants within Uber Eats. That's done with the large language model.
In a way, it is a little bit of this recommending with LLMs.
Yep.
Especially on that first use case you were talking about, where you understand me, I'm a vegetarian, I go on to Uber Eats, you don't show me any food, and then when you talk about different restaurants, you're not going to highlight their meat dishes, you're going to highlight their vegetarian dishes.
Exactly. So in the past, I don't know if you noticed this, in the past, if you log on to the Uber Eats app, we have these carousels, right?
Yeah.
In each carousel, we show different restaurants or dishes. And in the past, we only have Korean food, Chinese food, burgers, hot dog. Very boring.
Yeah.
You look at it, you don't want to order. I don't want to order. It just says Korean, Chinese. It doesn't really intrigue me, right? Yeah. So what we do is first of all, we use the large language model, try to understand the menus and dishes from all our restaurants, then come up with that new set of carousel titles. Now we have spicy Sichuan food, meat lovers, and all those catching carousel titles. And then we use large language model to tag each of the restaurants with these new carousel titles. This is how we act. Then we use this information to match our eaters with the restaurants.
Oh, fascinating.
So that's how the large language model is used for recommendations.
Yeah, and I can imagine also you could do it with user reviews. Maybe not in Uber's case, you're not giving reviews after you eat, right? Normally?
We actually do, but not many people are doing that.
Yeah. That's I didn't even know that you had that. But in a way, it's like that sentiment. You can see if somebody or if there's many people that are ordering the same dish, then you can know that, all right, we really want to figure out how to message this dish correctly. It feels like it's a bit of predictive and generative ML, because if I'm ordering the same dish over and over, you don't need an LLM to be able to siphon that out, I guess. That's that's very clear tabular data in a way.
Yeah. But that's a very good point. Coming back to the review thing, right? We just launched a project, a GenAI project, into an online experiment. What we do is we we use the large language model to look at all the reviews for certain restaurants and also the scores and other sources of data, then try to summarize how the eaters actually like or dislike about this restaurant. Then we give that feedback to the restaurant owners. And they can make improvements on their dishes or on the services based on that feedback. So that's one of the projects. We call this customer feedback summary for merchants.
Are there any other interesting use cases that you like talking about or that you've seen and you kind of got your mind blown by?
I can talk broadly how machine learning has been used at Uber, from the predictive machine learning all the way to GenAI here. So, like at any certain moment, we have more than 5,000 models in production, making 28 million real-time predictions per second at peak. So that's a scale we are operating on, and everything happens on Machanjo. Sorry, I have to brag. So virtually every single interaction our users have with the Uber app involves machine learning under the hood.
Wow.
Let's take the rider app, for example, right? This is all predictive machine learning so far. So when you try to log into your account, we actually use machine learning to detect if this is actually you try to log into your account. We call this account takeover.
Oh, wow.
Yeah, this is part of our fraud detection mechanism here. Yeah. Once you log in, machine learning used for, when you search for a destination, is used for search, right? It's used for ranking your search results. And once you identify your destinations, then machine learning is heavily used for match you to the driver, for the pricing, for ETA calculation, even to recommend the right product to you. I don't know if you notice this. If you open the Uber app, it actually shows you a lot of different, like Uber X, Uber Black, Uber Blue, everything, right?
Comfort, all that.
Yeah, actually that list is personalized. Everyone sees different list.
Uber thinks I'm way richer than I am because they're always recommending me comfort. I'm like, give me that cheap option. Why are you giving me the more expensive
Sometimes
one?
machine learning knows you better than
I know. I don't like that. I don't like that at all.
Okay.
I do choose comfort though. They got me. I'm a sucker.
Okay. I let our product recommendation team know. But coming back to this, right? All the way to like where you're on trip, we give you the real ETA. That's also machine learning, and all the way to payment, fraud detection in payment, also the customer support. Now we use GenAI for customer support. Then if we take the Uber Eats app, it's the same story. Machine learning is everywhere. We focus more on the personalization, recommendation, and also ETD. So these are ETD's estimated time of delivery.
Oh, yeah. Okay.
So that's on the predictive machine learning side. Now let's talk about GenAI, right? Yeah. If we look at the GenAI use cases at Uber, we can roughly divide them into 3 different categories. The first category is, we call this magical user experience. These are the generative AI applications that directly impact our end users. For example, any of the chatbots, our customer support chatbots. Yeah. We also have this Earner Copilot. We build a Copilot chatbot for our drivers to answer their questions, to guide them where you drive so that you can maximize your earnings.
Oh, cool.
Things like that. It's still in the works, but that's something in progress. And something else like the personalization experience I just mentioned. That's one of the use cases belong to the magical user experience. Then the second category here, we call it process automation. We basically use generative AI to automate some of our internal processes, or further automate some of our internal processes. And for example, we use GenAI to generate the menu item descriptions for restaurants. Because a lot of times if you log into Uber Eats app, you will see a lot of the menus, they only have the title. The dishes, they only have the title. There's no description at all. So we're using GenAI to generate descriptions for 100% of all the dishes on Uber Eats. Wow. And what else do we do? We also use GenAI to try to identify like fraudulent accounts. One of the key characteristics of this fraudulent account is that their usernames are usually gibberish usernames. Like
Interesting.
Yeah, like I love dog. That's
Yeah.
probably not a real person.
I thought it was just like FXYW by.
Exactly,
Yeah.
exactly. So we use large language model to scan through all the accounts, try to identify these,
Oh, fascinating.
potential fraudulent accounts. Something else in terms of in this category is the driver background check. When the new drivers, when they try to onboard to the platform, we do very thorough, strict background check for each of the drivers. And we use large language model to accelerate that process.
Oh, wow.
So that's the second category. We call this process automation. And then with
process automation doesn't have anything to do with like back office processes of, hey, like in a way, bureaucracy of we need to do something. And if I want to submit time off, maybe that's
the third category.
Oh, okay. What do you call that?
We call this internal employee productivity.
Okay. Yeah, that makes sense.
This is where we build all those tools.
Yeah.
As you mentioned, the workflow automations. For example, we also have this, we build this data GPT, which is because Uber has vast amount of data. And we have so many data scientists, product analysts. They need to analyze the data every day. Today, they do that by writing SQLs. So we built this data GPT to help them, first of all, write better SQLs. And second, just query data with a natural language. So that's one of the internal employee productivity projects.
This text to SQL is becoming a very standard GenAI use case. You see it in so many companies, and that lift that you get by allowing the data analysts to write more queries more quickly or just get answers quicker is very valuable, and it's something that you can show value really easily. The other stuff, maybe it's debatable.
If you do it right, let's keep that in mind. You can do things really fast, but it has to be. You have to give your correct answer. That's the key.
Yeah, because you can spend 20 minutes trying to get a simple answer because you didn't do it right.
Yeah, exactly.
Yeah, so you're talking about doing it right from the end user perspective, not doing it right from the infrastructure side of things and how you're architecting the agent to go in and write the SQL.
Both, right? Because you're from the infra side. If you do it wrong from the infra side,
you're screwed.
Yeah. Let's forget about end user experience. Yeah.
Exactly.
Yeah.
There is another thing I wanted to talk about, which is the scale and all of this inference. And what are some gnarly challenges that you've gotten into because of the amount of models that you're using? And you're now using not smaller models, but you're using all these predictive models. And so those have a certain style and flavor of needing to use inference. And then you're using the generative models, and those are a different style and flavor. And so how do you attack that within Michelangelo to be able to serve both of those?
Yeah, very good question here. So I think there are a few things we did to enable generative AI to extend Machanjo from supporting the predictive machine learning to generative AI. First is the compute resource, the compute amount is totally different.
Yeah.
Right now, you need a lot more GPUs and high-end GPUs, H100, all those GPUs.
Tier 4 doesn't get that kind of stuff, huh?
Usually,
Tier 4?
Usually no. Oh, by the way, that's a very good point.
4. Yeah.
So we prioritize higher tiers over lower tiers for sure.
Yeah.
We also prioritize production jobs over offline training jobs, batch jobs. That makes sense, right?
Yeah. Okay.
So that's how we prioritize. But coming back to the infra change for GenAI, so that's one thing. We need to procure more compute resource. That's the prerequisite for you to do anything for GenAI, right? And secondly, the tech stack has to change, has to evolve. But for GenAI models, because now the model is much larger, right? It doesn't fit into one GPU. Usually it doesn't fit into one GPU, so you need model parallelism. For the traditional deep learning, usually you can get by using data parallelism. Yeah. It's totally enough. So to enable GenAI, because of this restriction, we actually integrated deep speed and use deep speed in junction with Ray.
Both together.
Oh yeah, you have to. One is the orchestration layer, the other is the model optimization layer. So use both for large language model fine-tune. We also enabled Triton from NVIDIA for serving large language models. And now we're actually using the same infra to serve one of our large traditional deep learning models, like our recommendation models.
Wow, okay.
So it's not just for GenAI. We also use that for some of our traditional machine learning, which is really cool.
Wow. So you had to add, it's almost like you had to add a few new tools into the tech stack. But then when you did that, you found those tools help for the other stuff.
It's actually useful for something else we've already doing for years. Yeah.
For those bigger deep learning models, but not for the smaller models.
No, not for tree models like HGBoost. You don't need that.
Yeah, it's not needed.
Yeah.
And then they can choose what they want as far as that, or you're the one that's optimizing the inference?
On the inference side, it's us. Yeah. But when we talk about optimization of serving a model, right? It's always two things. One is the optimization on the inference side. That's what we do. Yeah. The other thing is on the modeling side. That's what our users do.
Yeah.
For example, you can quantization. That's something they should do.
Yeah.
But we should support quantization, quantize the model serving. Yeah. That's on the inference side. It's always a collaboration. We also collaborate with other teams.
I imagine they're coming to you all the time asking you for support for certain things, like, now we want to distill this model. Can we figure out how to make it easier for us to distill it or compress it or quantize it, all of that?
Yeah.
How do you go about choosing, because there's no tiers there, is there? Or are you still bringing back in this idea of the impact?
They're still impact-based. Yeah. There are GenAI use cases with larger impact compared to the other more experimental GenAI projects. So even they're still tier 3 today because they're not in the core user flow, but they still can prove their impact, business impact. So as long as they can prove their business impact, we can prioritize.
When we talk about generative AI use cases, how are you looking at the agentic use cases? And when the agents are going and doing things, at the end of the day, it still is just, hey, you've got models, you're focused on that inference of those models. Are you adding extra infra support for the agents, quote unquote agents? Because as we said before, it's probably good to define what you think when you think of agents. But in my eyes, it's like the LLMs or the generative AI that can go and actually do stuff as opposed to just giving you these answers.
Yes. So starting this year, our focus has shifted to support exactly what you just mentioned. We want to actually enable Uber to build agentic AI systems going forward. So we're extending Machanjo. So in the past, we call that more like model studio, where you manage your models and all the relevant components related to model training and serving. Now we want to also build a agent studio for agent ops, for you to actually build, evaluate, deploy your agent, and manage your agents. So that's something actually in the works. I just got out of a meeting this morning with our engineering team, who is actually building this tool right now.
That's very cool to know. So how are you looking at it, and is it any different than the other stuff? Or if so, maybe the better question is, how is it different?
So in the past, all that we care is the model. We make sure you can train the model, then deploy the model to endpoint. Now you can call the endpoint to make predictions.
Yeah.
That's what we care as the platform team. But the agent is different. Agent is application by itself.
Yeah.
So we're now at the application level. So we have the model studio here, then agent studio on top of model studio.
Yeah.
The agents in the agent studio will leverage the models you build in model studio. So it's at the whole application level. Now, how do you actually accelerate that agent creation, evaluation, and deployment flow? That's something we are actually evaluating and deciding. How do we allow our users quickly spin up some agents, evaluate agent performance, then go back to iterate on the agent and evaluate again and deploy? Same thing as what we do for models, but now it's more at the application level. Yeah. I think that's a major.
How do you make sure that the agent has the right permissions so you're not writing to some database that it shouldn't be and all that stuff?
Very good point. Yes, very good point. Because one of the major value prop of the Agent Studio on Machanjo is that no matter what model you use, we allow you to access Uber internal data and also Uber internal tools. And then the security question you just mentioned come into the picture. There are certain data you have access, there's certain data you don't have.
Yeah.
So to enforce that, we actually work with our NGSec team. We have engineering security team to work with them to build this security protocol for this agent.
So if I create an agent, then it knows my permissions.
Yes.
And it is only allowed to do those things.
Yeah, it's either yourself or your team.
Yeah.
So it depends on your authentication. Yeah.
But then the utopian scenario here is that you have this agent studio and another team can come and grab my agent that I built and now start implementing it for their use case, or they tune it and do a little bit more, and now, cool, I'm up and running with an agent. I didn't have to build it from scratch.
Exactly.
But the big question in my mind is, does it automatically know that now it's another team, it's another person, and now they have these permissions?
It should.
Yeah.
It should. So we're still building this. It's not in place yet, but we're still building that. And the thing you just mentioned is actually we call it agent registry. So we have a repo of all the agents built within Uber, and every single team can look into look at that agent repo to see if there's anything already existing, so that I can just reuse or
I
build
knew
on
you were
top.
going to have that because you have the model repo. That's classical one. Most folks have that, but then I've read the prompt toolkit blog that you have.
Yeah, the prompt repo, yes.
And you have the prompt repo, which is another great one, and where folks come and they see, oh, here's a prompt for this model, and it is for this specific thing. Somebody already spent the time to tune this prompt. I don't have to start from zero.
Yes. And now we have agent repo.
Yep.
We're also building the MCP repo.
Oh, really?
MCP is a cool thing now.
Yeah.
So I want to build MCPs for a lot of the Uber internal services, so that it can be leveraged by the users to build agents.
You're thinking, all right, well, all of the internal Uber tools should have their own MCP server.
Not all of them, but some of them.
Yeah.
We look at which tools are used a lot today by our users. Then we want to build MCP for those tools.
There's agent builders and then there's tool builders in a way.
Yes.
And maybe it's the same person.
It can be the same
It
person.
just is that depending on the state or their moment in time, they're building tools or they're building agents. But at the end of the day, I think all of us want to be building agents.
Yes.
And not as much tools.
Yes. But at Uber, usually the tool owners, they build the MCP server for that tool. And that will be used by all the other agent builders.
And then they'll say, hey, this is standard practice. This is what we want you to use the tool for.
And I publish my MCP server to a MCP repo. Now, read the documentations to see if this is useful for you. If yes, follow this and to use it.
Yeah.
That's how we envision that. It's still in the works.
Yeah. I can imagine you'll come up with some cool stuff again, because you can throw AI anywhere, right? Or ML on helping folks select tools.
Oh, yeah.
And helping that search, getting that search really clean on, I want this. And so it's almost like I describe what I want, and I see a world where that internal tool can look like, okay, maybe you want to use these agents, or maybe you want to use these servers, MCP servers, and they have these tools that you can leverage.
Yes.
So we talked about supporting different inference, right? But what about supporting different evaluation?
So I think evaluating a GenAI applications or agent is a totally different story compared to our old evaluation for the predictive machine learning, where you just, you know exactly what metrics you're looking for. You measure the AUC, precision, recall, and you have standards pipelines or standard
maybe
frameworks.
Maybe ground truth.
Yeah, exactly. To measure the accuracy there. But for GenAI, it's totally different. I think this is still a problem the whole industry is trying to figure out how to do the evaluation right. But at Uber, we built our own, we call it GenAI evaluation frameworks, which allow users to do two things. One is the LLM as a judge. Basically, use another LLM to judge the output from these LLMs. I think that's a lot of teams out there in the industry are using.
Yeah.
The second is to include the human in the loop. Basically, whenever you need human to make a judgment, you just involve the human to do evaluations. Those are the major two methods we're using today. And also the third one is, of course, you can provide a golden data set even for your GenAI use cases, right?
Yeah.
Provide a golden data set, then use a golden data set to evaluate performance. Those are the few things we've been working on.
Sweet, dude. You wanted to touch on that?
So we're actually open sourcing Machanjo. Do you want to touch base on that?
No.
We are.
What?
Yeah.
Holy shit.
Yeah.
Really?
Yeah. Our plan is in 2 years, open source a full Machanjo, starting with our orchestration framework called Uniflow.
Wow. That's huge news. That is so wild.
Yeah.
So you're open sourcing first the orchestration framework and then everything else?
Yeah.
And it's going to come out in spurts, or it's going to come out, you basically have to clean the code base?
Oh yeah, a lot of cleaning work.
Yeah.
In the works. Yeah, we have to clean the code base. And our plan is to, at least for this year, 2025, we want to selectively work with some enterprise partners in a closed source fashion.
Yeah.
So we give access to them to our open source repo, and they can contribute.
Wow.
Then next year, we probably want to fully open the repo to the whole.
That is so cool. That's why I was asking about the prompt toolkit.
Mm-hmm.
And if it was ever going to be open source, then
It would be open source.
Yeah.
Probably in H2, sometime Q4 maybe. Yeah.
This year. Oh, so there's going to be some things that will come out super fast.
We already have something. Oh, but again, this year is all closed source. Only those few partner teams have
closed
access.
open. Yeah.
Closed open.
Yeah.
Yeah, but next year we try to fully open.
Wow.
The whole thing. Yeah.
That's so cool. Why now?
Well, when Machanjo started, back in 2016, there were not many options out there. So we had no choice. We had to build everything by ourselves from scratch. Of course, we use open source technology like Spark and other things. But then fast forward 10 years now, 9 or 10 years, there's so many startups out there. All the cloud players, they provide their own MLOps tools, and there's such a huge MLOps community out there like yours. So we do think allowing external contributions to Machanjo can actually drastically accelerate the innovation of Machanjo. Wow. That's why we want to open source this. Yeah, which in turn will benefit our Uber ML community. So yeah. And also the other thing is now we are in this era of GenAI, right? And GenAI, if machine learning has been advancing so fast, GenAI is even faster. So our team, we have 100 people, but still it's a smaller team compared to the whole community. It's hard for us, to be honest, it's hard for us to keep up pace with all the advancement in the industry. So again, that's why we want to allow the external contributions so that we can keep ourselves always at the front of the technology advancement.
All right, so that's awesome. Now, I always wondered what it would be like to work at Uber. I am not the big company type. I think I would get fired very fast. HR would have a problem with the things that I say. But I want to know, what do you like working at Uber, and what do you not like about working there?
Sure. I think what I like, first thing first, the engineering team. The Machanjo engineering team is truly world class.
Yeah.
Move really fast, highly capable. They can get shit done. Okay, let's put it that way. And incredibly collaborative, very supportive of your PM work. So as a product manager, I could not ask for a better engineering partner. That's the thing I like. That's the thing I like most about working in my current position. Secondly, personally, I do believe product management is the best job in the world if done right. If done right, and I'm deeply passionate about AI and MLOps. So my current job is a perfect combination of both. So I really enjoyed every single minute for the past 4 years at Uber. What else? Since, as I mentioned, since all the Uber's machine learning use cases, AI use cases are managed at Machanjo, it gives me this front row seat, right, to see how machine learning is actually driving business impact across Uber. So from pricing to recommendation yields to fraud detection all the way to GenAI chatbots, it has been a fantastic experience, I want to say. Yeah.